Hello dear students, welcome to a new video of I square. So now we are moving to the chapter matrices, and we have seen in the last class that what is a matrix, what is the order of a matrix, and we have related some situations to matrices. So in today's class we are going to deal with what are the different types of matrices. So I have written in the board three types of matrices. They are column matrix, row matrix and square matrix. So we are going to discuss what is a column matrix, what is a row matrix and what is a square matrix. So coming on to the first one, what will be the definition for a column matrix? We know that a matrix is a square or a rectangular representation of numbers or functions, and it is written as columns and rows. So this is the example of a matrix which are always represented in rectangular forms in rows and columns. Suppose I will give an example of a matrix like this. This matrix has three elements and it is put in the first column. So this is the matrix A. Looking into this matrix, we can clearly say that this matrix have only one column. So the first element is A1 1 and the second element is A2 1 and the third element is A3 1. So this matrix have three rows, 1, 2 and 3, but it has only one column, that is this particular column. So the order of this matrix is number of rows by number of columns, right? So what is the number of rows? The number of rows is 3. So 3 by what is the number of columns? The number of columns is 1. So this is a 3 by 1 matrix and it has only one column. So the definition of a column matrix is that a matrix which is having only one column is called a column matrix. So what will be in general, what will be the order of a column matrix? The order of a column matrix will be always m by 1, where m is the number of rows and the number of columns will be always 1. So a m by 1. So the order of a column matrix will be always m by 1. So a matrix having only one column is called a column matrix. Moving on to the next one, what is a row matrix? Now you can guess what will be the definition of a row matrix. So consider the matrix B is equal to 5, 7, 8, 9. So this is an example of a matrix, and how many columns does this matrix have? How many columns does this matrix have? 1, 2, 3 and 4. So there are 4 columns and the elements are called A11, A12, A13 and A14, and we know that there is only one column in this matrix. So the order of the matrix is always number of rows by number of columns. What is the number of rows here? The number of rows is only 1. So 1 by number of columns is 4. So 1 by 4 is the order of this particular matrix, and this particular matrix have only one row. So a matrix which is having only one row or a single row is called a row matrix. So what will be the general form or the general form of the order of a row matrix? So we can clearly say that it will have only one row. So it would be 1 by, and it can have as many columns, that is it can have any number of columns. So let it be n. So B1 by n is the general form of the order of a row matrix. So that is, the row matrix is a matrix which is having only one row. Moving on to the next type of matrix, we have square matrix. What is a square matrix? A square matrix always have the same number of rows and columns, which means if a matrix have 3 rows, then it should have 3 columns, then it will be called a square matrix. For example, 2, 1, 7, 4. This is a matrix, let it be C. How many rows this matrix have? It has 2 rows, okay. How many columns it have? It have 2 columns. So the order of a matrix is 2 by 2, which means the number of rows is equal to the number of columns. Consider another example, A, B, Z, Y, P, Q, 3, 4, 7. So this is a matrix with how many rows? It has 3 rows and how many columns? 1, 2, 3. 3 columns. So the order is 3 by 3. So here also the number of rows is equal to the number of columns. So a matrix whose number of columns is equal to the number of rows is called a square matrix. So what would be the general form of a square matrix? If n is the number of number of rows, then n should be the number of columns too. So if the number of rows and number of columns are equal, then we can clearly say that it is a square matrix. Now we shall see another types of matrices. So now we are going to learn what is a diagonal matrix, scalar matrix, identity matrix and zero matrix. So before going to know what is a diagonal matrix, let's see what are the diagonal elements of a matrix. Always remember that square matrices have diagonal elements. What is a square matrix? A square matrix is a matrix having same number of rows and columns. So let me give an example of a 3 by 3 matrix like A, B, C, 1, 2, 5, 7, 3, 4, 6. So we know that this is a 3 by 3 matrix. And we know that this is A11, A12, A13, A21, A22, A23, A31, A32, A33. So these are the elements in this 3 by 3 matrix. See this is a square matrix. So the elements which is like this is called the diagonal elements of a square matrix. Which are the diagonal elements here? The diagonal elements are A, 5 and 6. So look at this, A, 5 and 6 are the diagonal elements of this square matrix. So see the peculiarity of the diagonal elements. They are in general A11, A22 and A33. We know that in general an element of a matrix is of the form Aij. And look at the diagonal elements. Look at the suffixes of the diagonal elements. The I and j are equal. So the diagonal elements of a square matrix is always the set of elements Aij such that I is equal to j. It is the set of all Aij such that I is equal to j. So the diagonal elements will be always A11, A22, A33 for a 3 by 3 matrix. For a 4 by 4 matrix, it will be A11, A22, A33 and A44. So hope you understood what are the diagonal elements of a square matrix. So coming on to the diagonal matrix. A diagonal matrix is a matrix whose non-diagonal elements are 0. So we know that diagonal elements are always for square matrices. Let me give you an example of a square matrix like this. -1, 0, 0, 2. So look at this matrix. This is a square matrix with order 2 by 2. So look at the diagonal elements, that is minus 1 and 2. And what are the non-diagonal elements here? The elements which are not in the diagonal, they are 0 and 0. So a matrix is called a diagonal matrix if all its non-diagonal elements are 0. So always remember that a matrix is called, a square matrix is called a diagonal matrix if all its non-diagonal elements are 0. Let me give you another example of a diagonal matrix. Let it be minus 1.1, 0, 0, 2, 0, 2, 0, 0, 0, 5. So we can clearly say that this is a 3 by 3 matrix because it has 3 rows and 3 columns. And which are the diagonal elements? They are negative 1.1, 2 and 5. So look at the non-diagonal elements of these matrix. They are all zeros. So in this particular matrix also, all the non-diagonal elements are 0. So this is a diagonal matrix. So always remember that a diagonal matrix is a square matrix whose non-diagonal elements are always 0. So now let's move to scalar matrix. What is a scalar matrix? Okay, a scalar matrix is a diagonal matrix. Always remember that a scalar matrix is a diagonal matrix. So consider a 2 by 2 matrix. So it will have 4 elements in 2 rows and 2 columns. So since it is a diagonal matrix, all the non-diagonal elements will be 0. So a scalar matrix is a diagonal matrix whose diagonal elements are same. So if I put 2 here, I have to put 2 here also in order to make this matrix a scalar matrix. So what is the definition of a scalar matrix? It should be a diagonal matrix. A diagonal matrix is a matrix whose non-diagonal elements are 0. And one more condition is there, that the diagonal elements should be same. So in general, we can say that Aij equals to 0 if I not equals to j. We know that this is A11, this is A12, this is A21 and this is A22. See this I not equal to j. Here A11, 1 equal to 1. But A12, 1 is not equal to 2. So we will put 0 there. And A21, 2 is not equal to 1. So we will put 0 there. And A22, I is equal to j. And also we have all the Aij's same for I equals to j. So this is the definition of a scalar matrix. For a diagonal matrix, the definition would be like this: Aij equals to 0 for I not equals to j. So this is the definition for the diagonal matrix. The non-diagonal elements, which means whenever I not equals to j, then Aij must be 0. So that is the definition for the diagonal matrix. And for a scalar matrix, it is a diagonal matrix with the diagonal elements same. So hope you understood what is a diagonal matrix and what is a scalar matrix. Let me give you another example of a scalar matrix. Let it be 3, 0, 0, 0, 3, 0 and 0, 0, 3. So this is a 3 by 3 scalar matrix. Look at this. This is a diagonal matrix because all the non-diagonal elements are 0 and we have the diagonal elements same as 3. So this is a 3 by 3 scalar matrix. Now let's move to the next type of matrix. It is identity matrix. What is identity matrix? So identity matrix is a square matrix whose diagonal elements are 1. So since it is a square matrix, all its diagonal elements should be 1. It is a square matrix whose all the diagonal elements 1 and all other elements 0. So it would be like this. All the diagonal elements are 1 and all the other elements should be 0. So look at this particular matrix. We have the diagonal elements 1 and the non-diagonal elements 0. So this is also a diagonal matrix. This is also a scalar matrix, and a scalar matrix whose diagonal elements are 1 is called an identity matrix. So in an identity matrix, all the diagonal elements will be 1 and the non-diagonal elements will be 0. So how will we write the general form? We will write it like this. Aij is equal to 1 if I equals to j, and what else? Aij equals to 0 when I not equals to j. So this is the condition for the identity matrix. All the diagonal elements will be 1 and the non-diagonal elements will be 0. So moving on to the zero matrix. Zero matrix is a matrix whose all elements are 0. For example, this is an example of a zero matrix whose all elements are 0. Again, we have another example for zero matrix like this. All the elements are 0. So zero matrix is a matrix whose all elements are 0. So in today's class, we have learned different types of matrices, including column matrix, row matrix, diagonal matrix, square matrix, scalar matrix, identity matrix, and zero matrix. So always remember the criteria for different types of matrices, and you should be able to write an example of all the types of matrices whenever they are asked. Now let's see what is the criteria for equality of two matrices, or when can we say that two matrices are equal. When will we say that two matrices are equal? There are two conditions for two matrices to be equal. Which are they? If A and B are two matrices and it is said to be equal if they are of same order. If A and 2 are two matrices and if two of them should be said to be equal, the first condition is the order of A and B should be equal. If A is a 2 by 3 matrix, then B should also be a 2 by 3 matrix. If A is a 4 by 2 matrix, then B also should be a 4 by 2 matrix. So the first condition is the order of both the matrices should be equal. Now the next condition is each element of A is equal to the corresponding element of B. That is Aij equals to Bij for all I, j. So if 1, 2, 3, 7 is a matrix A and B is 1, 2, 3, 7, then we have to check whether A equals to B. Here A is a 2 by 2 matrix because A have 2 rows and 2 columns, and B is also a 2 by 2 matrix because B also have 2 rows and 2 columns. So the first condition is satisfied. It has same order. Now what about the first one, that is A11? Corresponding to A11 here we have B11 here, and it is clear that A11 is equal to B11. Again, this is A12 and this is B12, and here also A12 is equal to B12. So the corresponding elements of the first rows are equal. Now coming to this one, this is A21 and this is B21. So clearly A21 is equal to B21. So this element is also equal. Now corresponding to this we have A22. So A22 is equal to, and this is B22. So A22 is equal to B22. So we have Aij is equal to Bij for all I, j in the case of these two matrices. So we can say that A is equal to B. So let's check another example. Another example is like this. We have two matrices. B is equal to 1, 2, 3, 4, 0, 0, and C is equal to 1, 2, 3, 4. Are these matrices equal? First of all, we have to check whether the matrices are of same order or not. What is the order of this matrix? 2 rows and 3 columns. So it is 2 by 3 matrix. And this is a square matrix whose order is 2 by 2 because it has 2 rows and 2 columns. Look at the orders. This is a 2 by 3 matrix and this is a 2 by 2 matrix. So the orders are different. Hence we can directly say that both of these matrices are not equal. So we denote equal matrices like this. A is equal to B. And we denote not equal matrices, അതായത് non-equal matrices like A not equals to B. We use equal to sign and not equals to sign to denote the equality and inequality of matrices. So we have here B not equals to C. So we can write it like this, B not equals to C. So this is the criteria for the equality of two matrices. Now let's solve some problems related to these concepts. So here we have a question. If these two matrices are equal, find A, B, C, X, Y and Z. So we are given that these matrices are equal. See, both of these matrices are 3 by 3 matrices and it is given that they are equal. So if two matrices are equal, we know that the corresponding elements will be equal in the both of these matrices. So we can equate the corresponding elements and hence find the values of A, B, C, X, Y and Z. Since the matrices are equal, we can say that x plus 3 is equal to 0. So x plus 3 is equal to 0, which means that x equals to negative 3. So we have found the value for x. Now we have z plus 4 is equal to 6. So z plus 4 is equal to 6, which means z is equal to 6 minus 4, which is 2. Again we have 2y minus 7 is equal to 3y minus 2. 2y minus 7 is equal to 3y minus 2. Solving this, we have 3y minus 2y, taken 2y to this side, is equal to minus 7 plus 2. So that is y is equal to minus 7 plus 2 is simply minus 5. So we got y is equal to negative 5. So next we have minus 6 is equal to minus 6. That's okay. Again we have a minus 1 is equal to negative 3. A minus 1 equal to negative 3. So a is equal to negative 3 plus 1, which is negative 2. So we got a is equal to negative 2. Again we have 2c plus 2 is equal to 0. So 2c plus 2 is equal to 0, which means 2c equals to negative 2 and c is equal to negative 2 by 2, which is 1. Sorry, negative 1. So we got the value for c also. Now we have b minus 3 is equal to 2b plus 4. b minus 3 is equal to 2b plus 4. Again 2b minus b is equal to minus 3 minus 7. So we have b is equal to minus 10. So hence we found the values of x, y, z, a, b and c. So this is the solution for this question. Since the matrices were given equal, we can equate the corresponding elements of both the matrices and hence we found the values of the required variables. Now we shall move to another question. So the next question is like this. Find the values of A, B, C and D from the following equation. We have an equation here and the equation tells that this particular matrix is equal to this particular matrix. So this is a 2 by 2 matrix and this is again a 2 by 2 matrix, and we are given with the equation is, we are given that the matrices are equal. So we can equate the corresponding terms of the matrix. It will be like this. 2a plus b is equal to 4. Again a minus 2b is equal to minus 3. Again we have 5c minus d is equal to 11 and 4c plus 3d is equal to 24. So looking into these two equations, we can say that this is a pair of linear equations in two variables a and b. So we can solve easily these equations by using elimination method. So for that I am making equation number 2 like 2a minus 4b is equal to minus 6. It is by multiplying the equation 2 throughout by 2. Again we have 2a plus b is equal to 4. So subtracting these two equations, we will get like this: minus 6 minus 4 is minus 10, minus 4b minus b is minus 5b, and 2a minus 2a is 0. So we have negative 5b is equal to negative 10. So b is equal to negative 10 by negative 5, which is equal to 2. So b is equal to 2. If b is equal to 2, we can substitute in this equation and find the value of a. What will be that? So it can be found out like this: a minus 2b, that is a minus 2 into 2 is equal to negative 3, which means a minus 4 is equal to negative 3, and we have a is equal to negative 3 plus 4, which is equal to 1. So we got a is equal to 1 and b is equal to 2. So now moving on to this equation, let this be equation number 3 and let this be equation number 4, and this is also a pair of linear equations in two variables, say c and d. So we use elimination method here also. So in order to make the coefficient of d common, I am going to multiply this equation throughout by negative 3. So it will become minus 15c. Again we have plus 3d is equal to negative 33. Again we have 4c plus 3d is equal to 24. So I am going to subtract these equations and we will get negative 33 minus 24, and it is negative 67. And again we have 3d minus 3d 0, and negative 5c negative 4c, and we will get it like this: it is negative 19c plus 0 is equal to negative 67. So we have c is equal to negative 67 by negative 19, and it is simply 3 because 19 times 3 is 67. So we got the value of c as 3. So c is equal to 3. So now we can substitute the value of c in either of this equation. Let us put it in this equation. So it will become 5 times c, that is 5 times 3 minus d is equal to 11, which means 15 minus d is equal to 11, which means d is equal to 15 minus 11, which means d is equal to 4. So we got d is equal to 4, and we have a is equal to 1, b is equal to 2, c is equal to 3, and d is equal to 4. So that's the end of this question, and that's the end of this particular class. So in today's class we have learned different types of matrices and the condition for equality of two matrices, and we have solved some important problems regarding these two concepts. So in the next class we will move to do the exercise regarding all these concepts. So till then, wait for the next video. Thank you for watching. Bye bye.